VOD yet. And if you're not familiar with this series, if you haven't checked out any of the other shows we've done all year, this is the show where we build projects live, right here in front of you. Various projects, some fun, some silly, some useful, and it's all made possible by our friends at Digi. If you're not familiar with Digi, they are an electronics distributor based here in the United States. They supply all the components that you need to build this project and tons more. And they ship really fast. In fact, at one point, like last Friday, I needed some parts for this project, and I made my order in the afternoon, and I had my door the next day. That's how fast they ship. Or that's how fast we have them ship. Which is amazing. Okay, how's it sound? How's it sound? Are we sounding good? Are we sounding good? All right, I'm hoping that this sounds good now. Still nothing. Hooray! 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 Great! Okay, let's start that all over again. Thanks so much for your patience. Welcome to the 12th and final episode of Make Live for 2017. My name is Tyler Weingartner, video producer here at Make. I'm joined today by Hep Swadia.
I'm the photo editor of Make Magazine.
And if you're not familiar with this show, this is where we build projects live directly here in front of you on the internet with all the things that can possibly go right or go wrong, and trying to work through the troubleshooting. And this live series is made possible by our good friends at DigiKey. DigiKey is an electronics distributor here in the US. They store all of the components that you need to build this project. In fact, if you look a little bit down there in the link below, you'll see a link directly to a shopping cart already set up with everything you need to build this project if you wanted to build one yourself. And I highly encourage you to, because this is a really good and crazy project. The other thing that's great about DigiKey is they ship super fast. I found myself on Friday needing some extra parts for this project because I'd bought some of the wrong things. And they had it to my door the very next day. And this was, I put this order together around noon on Friday, so that's crazy fast. But the thing we're building today is really dumb, and I love it. We are going to be using two of my favorite things. If you've been seeing any of these before, you know that I love the Adafruit Feather platform of microcontrollers. So we're going to use that. We're going to use the Adafruit Feather Huzzah, which is a Wi-Fi enabled microcontroller. And we're going to use the IoT app Blynk to create an internet-controlled confetti cannon that we're going to turn controls over to you, so that you can decide when it's going to fire. And I mean, by you, I mean all of you. If you look in the lower right-hand corner here, they're pointing the right thing, there's this QR code. If you go ahead and download the Blynk app now to your phone, that's B-L-Y-N-K. And the thing I want to stress about this, I know it sucks to have to develop or have to download an app to your phone, but you don't have to create an account or give up any personal details. All you need to do is download the app, and that's B-L-Y-N-K, scan that QR code, and then you'll be able to access the app that will then control this confetti cannon, which we'll be firing at the end of this stream once we build everything. So that's how this is going to go. I can't wait to get started, so I'm not gonna.
Let's do it.
All right. And of course, if you have any questions about this project, the build, or what is wrong with me, and why I would want to create a compressed air cannon and let the internet have control with it, put those questions into the comments below, and we will answer them as best we can. It's worth mentioning now that I put the camera in the way, this is the air cannon that we're going to be using. It's actually, I didn't get a chance to build this. Building an air cannon out of PVC involves a lot of glue up, so we did this ahead of time. In fact, I didn't do this one at all. This is a gift to us by our friend Jordan Bunker, who recently wrote a book about how to build projects with PVC. He's a good friend of ours, and we're happy that he loaned this to us. And if you want to get his book, you can have it available on Amazon. What is it called again?
PVC and Pipe Engineer. Putting together cool, easy, maker-friendly stuff.
Cool. And so that's how you can know how you can build stuff like this. All right, so what do we have here today? Let's take a look at the parts we're going to be using to control this thing. So let's actually focus this so people can see what this is. All right, this is the board I was mentioning earlier. This is the Feather Huzzah. It's a microcontroller with the highly useful ESP8266 Wi-Fi chip that lets you connect this board to the internet and do all kinds of fun things with this. Now, there are a number of I do want to talk a little bit about some of my inspirations for this project. One of my favorite things on the internet ever is projects like Twitch Plays Pokemon. And that uses a fairly simple scheme where Twitch is actually really easy to control hardware. And the way that system works is there was just a laptop that was signed into Twitch. And the nice thing about Twitch chat is that it's entirely based around IRC. So there's lots of different ways that things can connect to it, like a laptop. And then it can just parse the chat for commands and then inject those commands into a... well, in that case, it was just injecting the commands into a Game Boy emulator. But I've also found that you can use the same board to sign into Twitch chat. But we're not using Twitch today. And I wanted to be able to have a way to easily let people interact with streams and hardware on streams in any way they choose. And that's really the point of this project, is to... I wanted to be able to create an easy framework where people could create a system so live audiences could interact with whatever hardware people could dream of, like whether they want to have a sign you could light up or sort of a voting meter or something like that. I was chatting with my friend Vinny, who is the video director over at Giant Bomb, and he wants to have something that, like, when they're doing live streams, they want to have it like drop a new game on them when they're tired of the game they're currently playing. There's all kinds of fun stuff with this, and my hope is that you'll be able to adapt this to whatever thing you want. So this is one of the other components we're using here today. Basically, the way this is going to work is there's a button that, if you've already downloaded the app, you'll see that there's a button you can mash, and that's going to make this counter go up. And it's going to go up until it reaches a number that we decide on when we get into the code. And when it reaches that number, that's when the confetti fires. So it's this cool 7-segment display. It's going to glow bright white. It's going to look really cool. And it comes along with this controller board that we need to solder it to that handles all the control for it. So all you need is connections for the system called I2C, which is sort of a serial-based connection for Arduino and other microcontrollers and things like that. So not only does it look cool, it's super easy to use. In fact, let's get this soldered on here right now.
So the chat wants to know about how long we expect this build to be.
This is where I always run into trouble.
You say a number and then...
And then it ends up being totally wrong. I always say this. This is a pretty simple build. But...
knock on wood, or...
No build is really simple. I'd like to think that we might be done in maybe 90 minutes? Let's say 90 minutes.
We'll shoot for 90 minutes. But this build, luckily, was developed by Tyler, so hopefully we've already encountered all of the problems.
I encountered quite a few of them. If you remember back to the cold brew coffee tower, I'm dealing basically with the same problem here, which is switching a low voltage. This is not good internet. Watching me fumble, try to get these header pins lined up here. Switching a high voltage load with a low voltage circuit. And I went through so many of those same iterations here. And this one's even a little bit more complicated because the Feather boards use what's a 3.3 volt logic level, and there's many, many, many relays out there that require 5 volts. In fact, that's really common. And that was why I needed to get the quick order from DigiKey to get a relay that was going to work with it. But otherwise, really what we're doing is we're taking 2 of these Feather boards. One is the Wi-Fi board that I was showing you earlier, then a relay shield for it. Well, they call them, the traditional nomenclature calls them shields. Adafruit prefers to call them feather wings.
Which is cute.
It is cute.
I like that.
And then we're going to wire up this the 7-segment display. And we're going to attach it to our air cannon. We need to do a little bit with the code, mostly to
set the parameters of...
Yeah, we need to tell it where to, what number we want it to reach before you guys set it off. And then we're going to shoot some confetti into the air.
An end of the year party.
Let's see.
Nice job.
Did I get all these?
Looks like you did. Very smooth.
Take a quick look here. Yep, that looks like a decently soldered thing. We'll solder up these connection points here. So yeah, with using I2C, you only need these 4 connections. You need power, ground, and this SCL and SDA. And if I were a smart person, I'd know what those actually stand for. I believe one is like a data clock. So it keeps all the signals aligned and timed correctly, and the other one is just the data pin. And that's how you get data to this guy, the 7-segment display. All right, so that one is already soldered. Actually, I'm going to trim off these excess header pins.
And the chat is actually having an interesting discussion about how confetti messes up video. So we'll have to see at the end if that is true.
Oh yeah, I could see how the confetti, just because it's small, it basically presents a lot of detail and it moves quickly and chaotically, all of which video compression algorithms don't do well with.
They do not. They like orderly and not a lot of things happening.
It always cracks me up every time I see something on like HBO, and HBO still has that intro that starts off with like a burst of static.
Oh yeah.
And then it just looks terrible on any streaming display.
Yeah.
It cracks me up that they still use that. Especially because, I mean, you have to be a pretty old person at this point to remember what static looks like.
And they have that other great one with the killer song. Pretty sure that anybody that grew up in the 80s loved that HBO bumper song.
I don't know if I remember that one.
It was pretty good.
Okay.
Solid.
Take it under advisement. This is the other part that we are attaching to this. This is the latching relay feather wing. You don't necessarily need the latching relay feather wing. What the latching means is that, so normally the way a relay works is that there's an electromagnetic coil in this thing here that throws a switch. You activate the magnetic coil, it activates the switch, and that's how we can control a 12-volt load, or actually a 9-volt on the side of the air cannon using 3.3 volts. Normally when if you disconnect these from power, that electromagnetic coil will go back to its initial state. This one will actually stay there, so we need one pin to activate the coil and another pin to deactivate it. You don't really need it. It adds a little bit more safety to this project to make sure that, if you are trying to energize your confetti cannon, sometimes the non-latching relays might cycle when you first power it on, which can mean that it would fire when you didn't expect it to, and that's bad. You don't want that. So this should help out with a little bit more safety. Anyhow, let's get the header pins soldered onto it, then we can start assembling stuff.
Get some of the stuff out of the way over here.
All right, and I need another set of header pins. Oh, that's right, and there's the little terminal block that we need to solder onto here as well.
I can think of another good use for this would be New Year's Eve parties. You could have it count down to the new year, scare all your drunk friends. You forgot it was a New Year's party.
I just want to see what kinds of things the internet comes up with to use an internet-connected confetti cannon for.
I agree.
Nothing but good, dumb ideas to have with this. Another fun streaming channel that makes use of interactive hardware on the internet is letsrobot.tv. Now I'm totally blanking on her name. I think Jill?
I think so, yeah.
Creates robots that people can control on the internet. And she also does regular live streams of building robots and taking audience feedback on how the robot should interact with stuff. It's a really neat channel, and I encourage you all to check it out. That's at letsrobot.tv.
Blue JSA wants to know if there are any books or places you'd recommend someone to learn more about circuits besides YouTube videos.
Well, there's a couple of different. This is a good opportunity for us to plug our own content.
Yes, we have many, many books for all different kinds of circuits, whether you want to learn about specific microboards like Raspberry Pi or Arduino. There's the Getting Started series with all of those. Or there's more general electronics books like the books from Charles Platt.
Yeah, well, obviously there's like Getting Started with Arduino, which is great for learning to, getting your head around like what you can do with things like microcontrollers like the one I'm building here today. They're all sort of based around the Arduino Uno, which is kind of where this all got started. But there's a lot of different types of microcontrollers. And of course, there's the books by Charles Platt, the Make Electronics and Make More Electronics. And that's really dealing more with like really basic circuits.
Relays, all kinds of different logical pieces of different electronics. And if you want more interactive learning, we have a couple of workshops on Makershare.com. There's the Easy Electronics workshop, which is, I believe, pretty much no soldering.
Yeah.
And there's the Learn to Use a Breadboard workshop that teaches you about breadboarding and all the different ways that can be a method for you to enact your electronics projects.
If you've never, breadboard's sort of a funny name. It's actually the thing I'm using right now just to hold this circuit while I'm soldering the header pins on here. But it's basically a prototyping board that you can use to plug in components and test them out and test out circuits without having to do any soldering. Because you can just
make the connections other ways.
Mash the things into these into this grid of holes here. They make connections, electrical connections horizontally here. And it just lets you prototype and test your circuits really quickly.
And yes, as Daniel Ward said, we have a Humble Bundle up right now with tons of Make books. And if you keep an eye on Humble Bundle, there's a lot of those deals that go by with all different kinds of material in the various bundles to get you started on all sorts of learning paths. And we're almost done soldering this here. We kind of moved off camera, sorry.
Oh, sorry about that. Not following the advice I said in the workshop that we just launched, which is how to document your project, and that's look through the camera when you're doing critical work on it. And that's the way you can tell that what you're doing is still in camera.
And yeah, we should probably plug our own workshop. Me and Tyler and our community manager of Makershare, Matthew Dalton, just put together a workshop called Capturing Your Work?
Capturing Your Project.
Capturing Your Project. And it's all about how to photograph, video, or write about your projects.
All right, that soldering looks good. Going to pop this off of here. And still need to solder on, well, not before I throw it across the room, this screw terminal here. And that just makes it easier to connect the circuit for the solenoid on the air cannon. How do I want to hold this?
That's going to be a tough one. Maybe yeah.
I just set it on the desk here. Nope, that's not quite right.
You need a little crutch. No, don't use the battery. Is this big enough?
Maybe this bag. Maybe this bag? Good enough.
Yeah.
And that's off camera. I apologize for that.
Still off a little higher.
There we go.
And perfect.
Another electronics book that I'm really hoping to dig into, it's an older one in the Make library, is the Make Analog Synthesizers book. And there's a bunch of different analog synths you can make using the 555 chip, which is sort of an oscillator or timing chip, and then you can use it to make all kinds of cool amplified synthesizer circuits. You know, you kind of make stuff that makes old Atari noises and things like that. And I want to build stuff like that and hopefully get a better fundamental understanding of electronics through that process. So there's a couple more connections I need to make here, but I think in the meantime, I'm going to get these female header pins onto our Feather Huzzah board. And if you know of any boards that have a more fun name to say than that, please tell me. Get these other pins out of here. And I actually need one problem with these female headers, especially when you get them like this in sets of they're like half of what you need, so you need two of them, you need to set two of them side by side, is that they don't quite fit together, so you need to sand them down a little bit. Yeah, that fitting's a little bit tight there, so I'm going to grab a piece of sandpaper here.
Super good tip. See, I like these because I always learn something new from watching Tyler make things, because he has the time to watch all the crazy cool maker tip shows.
I think the really good tip here is use a higher grit or lower grit. Yeah, this is like 1500 grit sandpaper here.
And I think that's unfortunately like the...
Yeah, we're not well stocked in sandpaper at this point.
500?
500 would be a lot better.
Possibly too much better. We'll see. We're going to experiment. Opopo in the YouTube chat wants to know where the live IoT confetti cannon is. Well, we are building it right now. You can download the app called Blynk, which is B-L-Y-N-K, on your phone, and there's a QR code that you can see in the corner down there where you scan the QR code and you'll be able to interact with the confetti cannon that we built, and you will be able to hit the button a few times.
You will be able to hit the button as many times as you like until the confetti cannon fires. Is the crazy idea that we've come up with here. All right, let's see. If we've taken off enough material, we can get these to fit well together.
That looks like a much better fit.
Oh no.
Oh no!
I popped one of these little pins out. Looks like it
fits too well now.
Let's check our focus here. Let's pop that pin back down there.
Nice.
Okay, so that's one side done. Then let's get the other ready to be soldered together.
Daniel Ward said he already tried pressing it 15 times, hoping it would go off on our end.
It was funny because I mean, I've done tons of testing with this circuit before. And in fact, if you follow me on social media over the Thanksgiving break, I set up a test of it. All it was really was another one of these boards with a display on it, and people could mash the button and
nothing
make it
would happen.
And well, it
would iterate.
It would count up, and eventually it would show something that looked like an error. It was just a goofy thing just to test to see if this idea was actually going to work. But it's still using that same authorization code. So that's if you check that out, you already are set up to fire this cannon today. And in fact, I was testing out. I hadn't actually filled the cannon with confetti before earlier this week, and I wanted to, just test that one last little bit out. And as I'd had the thing filled with air and was stuffing it full of confetti, I noticed that the counter was climbing up, and I'm like, that's weird. Somebody was just mashing that button out on the internet, not knowing that they could have made something really exciting happen.
They probably would have mashed it a lot more. So we're going to get these together now.
All right, that's what I'm doing wrong, is I had the board lined up the wrong way. And I'm just using the other, the feather wing to kind of hold everything in place, so I know that they're already aligned to fit together well when I solder them. So a good thing to do when you're using like stacking headers is use your other boards to hold things in place so you know that they fit when you solder everything together. Because sometimes when you solder them, they can kind of fold and bend outwards, and then you've got to bend them back, and then that might damage your board. Messy things happen.
Or break a pin. Then you have to solder two things.
And then you have to, well, first you have to desolder, and that's the worst.
That's true. Unfortunately, we can't zoom out. Some of the chat are asking to zoom out. We zoom in at this level so that people can see which specific pins we're soldering. It's one of the trade-offs that we have to make in this format. These board packages are so cute and tidy.
Yeah.
I remember the days of just 80 different things together with long, unbraided wires snarling everywhere. I still do see projects like that sometimes, but I really like this new style of manufacturing and making everything a perfect little packet.
Although I almost, if you saw the last one, one of these we did, the live builds, was my...
Up a bit.
Yeah, sorry about that. My motion control camera slider, and I really tried to package that up with an enclosure that was like really neat and tidy and like hid almost everything. This one I did print up some parts that you can use as sort of I wouldn't really call it an enclosure because it actually leaves the boards exposed. But I think it was inspired a little bit by the design of the air cannon itself. And so I wanted something that looked a little bit prototypey and almost like a Ghostbusters proton pack or something.
It feels like, like a post-apocalyptic gun you made because you were trapped in the plumbing section.
Yeah.
Post-apocalyptic potato gun.
And, I mean, again, I love the way these 7-segment displays look. And you just have that, the exposed black box around them.
Yeah.
I mean, you can put them in an enclosure and isolate them, but...
I like that exposed wire look. It's pretty good. It depends on the project, but Mike X has the idea of what to use this for. Have it at the wedding, and then when the bride walks down the aisle, the guests can detonate the confetti.
Yes. Yeah, so there's a pretty old video on the Make channel by somebody last week was asking about Jason Pole Smith. This is one of his projects where he found I don't know where you find something like this. You'd have to ask Jason. He found a remote-controlled relay And he just used that to trigger the confetti cannon, you know, so he could have a little keychain remote and use that to remotely trigger a confetti cannon. This one's better because I can let the entire internet control the confetti cannon.
Yes. So Peter Myers just came in to ask how the confetti cannon is interactive. Well, we're glad you asked. This board that Tyler is soldering together over here will be connected to the Internet of Things and allow you to download an app called Blynk, which is B-L-Y-N-K, and you can scan that QR code that we have in the corner and you'll be able to press a button that will iterate the number up, and we will together decide on a number. When we hit that number, the confetti will fire.
I'm going to move in, sorry, the shaky cam here. I'm going to move in a little bit closer here. Make it easier to see while I'm working, and that should make it easier to make sure that you are seeing what you need to be seeing, just like I am, and I don't accidentally move things out of frame. So there's a couple of connections I need to make here. I mentioned earlier I need to, there's this set and unset pin. I need to solder set to pin 12, which is this one here, and unset to pin 14, and those will be what connect and release this relay here, which is what is going to fire our confetti cannon. And then I also need to wire up the connections for our display. So get some wire here and strip it down. First I'm going to make those tiny connections for the relay.
And if you are interested in relays, we have a really cool piece in the upcoming issue that will be coming out in, I believe, it will hit newsstands in February, but subscribers will receive it in January. About 4 different ways that you can use relays and all different kinds of relays and how relays work. It's a really great piece by John Wargo, one of our regular contributors.
John Wargo, also who wrote up a project that we built earlier in this series, the Arduino Twinkle lights.
Oh, I had forgotten that he made that one. I love that project. Another really good wedding project, by the way. If you need to make a bunch of maker stuff for a wedding, Make has got you.
And you could use this microcontroller board instead of the one that he suggested in there, which is one of the another board by Adafruit, the Trinket.
Yeah.
So that you could have it do something like, I don't know, have the lights respond to, I don't know, things going on Twitter, or again, you could let your guests control that if that's the thing you want to do. So there's lots of, I love this board because it's cheap, it's so compact, and there's just so much neat interactive stuff you can do with it. Trim this off a little bit here, and I need to strip the wire so I can solder it to pin 12.
And so we were saying set goes to pin 12 and unset goes to pin 14?
Yes. Flip that over and solder it from the other side.
The Italians are hoping for us to hurry up and finish because it's very late for them.
Oh no.
We are working as fast as we can. Thank you so much for staying up with us too. It's really awesome to hear that people on the other side of the world like our project so much that they want to stay up late. I remember those days from my own early maker days.
But, and granted, well, you would miss out on the opportunity to help contribute to firing the confetti cannon. but you can always, these are archived on our YouTube channel, so you can always watch them later.
Which is good if you want to try following along sometime and make the project on your own. Christian A asks how much the feather boards run.
They tend to be, I think there's a green wire for the unset pin. The base feather board, the Huzzah board that we're using today is only $20.
I think so, yeah.
And this add-on here, some of the, I think that's as expensive as they get. I can't remember there's the blue fruit one that might be 24. So, but they all tend to be relatively inexpensive in that price range. This relay wing that we're using today is only $8, and I believe they have a 7-segment display wing as well that I almost used for this, but Adafruit was in really short supply on it, so I wasn't able to get my hands on one. So instead, this is the 7-segment, I think they call it the I2C 7-segment backpack. It's only like $10 or something like that, with the control board and the display.
Oh, nice.
So yeah, this is
about a $30 total package for the electronics, plus your solder and wires and assorted other bits and bobs.
Yeah, one of the other add-on boards that I used in the last project in the motion controller was the OLED feather wing, and that one's really neat. That one is like $15, and that one's really neat because it also comes with buttons so you can make your own little user interface.
Cute.
I'm trying to, did I like somehow just stick this to the board? I guess that's not really going to be too much of a problem. It's a little messy, but I was trying to bend it up to trim it off. I think I like melted it to the board.
to the solder cover?
Yeah, to that actual PCB.
What do they call it? I can't remember. The screen printing stuff.
Yeah, I don't know. That's a question for Drew Festini.
It'll come to me at midnight tonight.
Drew's a good friend of ours that he's actually, even though he's based in Michigan, he's been in the Bay Area a lot lately.
He has been in the Bay Area a lot. Did he come out here and visit the office?
He did. But he works for a company called Osh Park that we like a lot.
Love and adore.
They, if you are building a electronics project and you want to make a custom board for it, rather than having to make a circuit on a piece of perf board or something like that, if you want to go into production or something like that, they are the company that you send your design files to, and they will do all the manufacturing of them for you, which is great if you're looking to start doing this professionally or sell a product. And the other cool thing about their boards is that they're always really easy to identify because they're purple.
Yay, purple boards! And yeah, we love Osh Park. They also have a lot of like learn to solder type things and solder challenging things. I ordered the SMD challenge kit that I'm going to attempt over the Christmas break, which is surface soldering a bunch of smaller and smaller LEDs down, and if you get them all to light up, you are a solder master.
Yeah, I wanted to try that, but I mean, if you see my hands here, they're my hands are I would not make a good surgeon. Okay, so those are those connections made onto the board here. Now we just need a few more connections for the I2C stuff, this SCL and SCA, and the 3 volts and ground. And also, shout outs again to Adafruit. I really love the fact that they printed these critical connections here onto the top board part of the feather. It's just the feather wing. It's just a really good, easy reference here. Which is something they haven't done in the past, so I hope they continue to do that, because it's great. Great, great, great. I'm going to continue to use our yellow and green wires here for our connections for the I2C stuff.
Solder mask. I knew I would remember it. That's what it's called. The silk screening that goes over the solder tracing.
So yellow is going to be our SDA.
Now, is that based on the logic of the other yellow, or just we like yellow?
We just like yellow.
It goes with the safety orange of the gun itself.
Yeah. Apologize, I'm kind of doing a little bit of this off camera. Once I get it clamped into this helping hands here, I'll get the camera reframed on it. Any other questions from the chat?
Ice Blue Scorpion wants to know where he can contribute his projects or her projects by make, or had your jobs laughed there. I don't know what that means, but you can contribute projects to make. Well, it depends, but the best address to go through is the editors@makezine.com address. Editors will see your projects. If you want to put it online, you can put notes in there that you want to put it on the blog. If you are trying to submit to the magazine, it's also a good way to submit to the magazine. The other good ways to do it is to tag us on social media, either on Facebook or Twitter or Instagram is a really good one because we get tagged way less there. So I am super sure to see your projects. If you tag us in them, either tag us in the image itself or just as a comment. Tag us.
Also, even before you do that, submitting, I mean, it's a good, like we check our project sharing site, MakerShare, pretty regularly for good projects. And if you submit your project there, that's a good place for, where it's already documented. And then if when you let us know about it, we'll already know where to find it.
And it's super easy for us to streamline that content right into either the magazine or the blog. So it's a great way to get your content up there, packaged perfect, a minimum of fuss for us to have to reach out to you for high-res images, or can you write this in this format, because the way that the site is set up is very, very similar to the way that we set up our own projects when we feature them in the magazine.
All right, so that is our SDA connection. Now we just need power and ground, and then we're going to be done soldering. Well, actually, no, that's not true, because we still need to solder the other side of these to the display board itself. That's not the right wire. This is the right wire. Get a decent chunk of this, and some black for our ground wire.
And you can see us here in the Make Lab. This is really where we make projects for the magazine. This area here is our studio, but it's also a working studio.
Third, the nice thing about a studio is it's got lots of lights, so that means it's also a really good place to build electronic projects.
So even when we're not shooting video, I tend to steal his video set to do all of my soldering.
I would call it a clean, well-lit place to do soldering, but it is not always clean. In fact, it's actually quite messy right now with all the confetti on the ground from all the testing of this project.
Yeah, over near our shredder, it looks like the shredder had an accident. I bet the cleaners just really wonder what goes on in here, because they'll come in and there'll be little bits of wire stripping all over, or whatever we built that day. The rubber chicken on the pegboard behind us, Mike X wanted to know why. That is a valuable tool here in the Make Lab for a number of reasons, but if you are ever familiar with Adam Savage's rubber chicken projects, that would be the actual place that it came from.
The duck bomb.
Yes. Do you want to switch back to the overhead?
Oh, I probably should do that. Thank you for reminding me. All right.
And right now we're just wiring power, right?
That's our ground connection. And now we need to be out of focus here for a little bit while I poke in our 3 volt or 3.3 volt power connection. Flip this over and clamp it into place. Where are we here? There we go. Clean the soldering tip a little bit and make one of our last soldering connections. Where did my stick of solder go? Apologize to our UK friends who have to put up with me calling it soldering and not soldering.
That is so strange to me. That's how you can tell where somebody is from, by the way, how they pronounce solder. And the right way to pronounce it is solder. So
I can't remember what website ran it, but there's a really fantastic test you can do where it like asks you how you pronounce various words, and it tries to predict based on your answers. And it's a pretty in-depth. I think there's like 60 questions where you came from.
I think I remember that one.
Yeah. You know, whether you say soda instead of pop to describe carbonated beverages, well, the non-alcoholic variety, and trim these all off the same length so they're all connecting into the same place. And gonna strip them all together.
I took that test and it guessed me as San Bruno, not San Francisco, which if you are familiar with the Bay Area,
that is
small.
hyper specific.
Yeah, it is a small suburb about 5 miles outside of San Francisco, where I actually am from. I'm from the tiny town right next to it called Brisbane. So it was really interesting to see that it actually pegged me not only locally, but hyper locally to about like 500 feet from where I'm from. Oh yeah, doing it with Jason says niche is a fun word too. Based on how you say that word, you can tell a lot about where somebody is from. And Opopo wants to know if there's a reason that you don't pre-tin your wires.
That would probably mostly because we're working a little bit quickly here because we have people in Italy waiting. Normally I would do that, but I find that for the most part they tend to get tinned, and if I'm wrong, please tell me. They tend to be tinned right along with as you solder them to their connections. That may not be the right electrical engineer's method of doing it, but I haven't found that my connections are unreliable as a product of doing it in this way. But again, I could be wrong. It's not like I'm a video guy. I'm not an electrical engineer. So
we're makers, not professionals, so we cut some corners sometimes.
Yeah.
And especially in the interest of today, we want to get to the part where you guys get to mash the button and we get to see the amazing colorful confetti that Tyler made earlier.
And by made, she just means took some construction paper left over from her project and fed it through a paper shredder.
There are many ways of making. Some of them include robots, such as paper shredders. Manta Ray wants to know what tinning the wires does.
I can tell you what it is, and that's where, so these are what's called, see how close we can look. We have a really good close-up lens for this project today. If you look at this wire, you can probably tell it's made of a bunch of tiny strands rather than what's called solid core wire, which I can find a scrap of here. Solid core is just where you have a single big fat conductor. And this is made, and otherwise the stranded wire, the green one here in my left hand, is made up of tiny strands. And tinning is when you would do a little bit of solder just to bind it all together into something closer to like the solid core wire. As for what it does electrically or conductively, I would defer to the question of the person who asked why I'm not tinning.
Well, Popo says that the way that you solder, not trying to be picky, you're applying the solder to the iron and it burns off some flux, which can cause problems with connections, especially with a bigger gauge wire or lower wattage iron. So that is super useful advice.
Okay, that's good to know. There's also what is referred to as tinning your soldering iron, which I can demonstrate here in a little bit. Which is where you just, on the tip of your soldering iron, where is it? Here it is. Just dab a tiny little bit of solder onto it. And that also helps make connections, it helps heat conduct much better. I think the science is it just, because you already have this solder that's in a near liquid state, when you touch the soldering iron to the through-hole connector ring and the component you're soldering, the pin of it, it makes better contact because it has this semi-liquid bit of solder there, and that just helps the heat conduct better. It's counterintuitive when you're doing something like desoldering, but sometimes it helps to tin your soldering iron and get a little bit more solder in there, and that'll help heat conduct through the entire joint and make everything a nice liquid state that's then easier for your solder sucker to remove. It doesn't make any sense, but sometimes you have to add solder to remove solder. I'll apologize, these are some of the worst flush cutters I've ever used. They're not great.
Do we have any other ones over here?
I don't know. I don't know where.
Well, I lost like all of them. These ones might be a little better.
All right. Our next connection is yellow, and that's our SDA connection for the I2C stuff. That one's done. Any more entertaining commentary?
Jim Bashir is, sorry if I'm pronouncing that wrong, says, Flux is life. It's also cool to put a little in the brim of someone's hat so they grease their forehead. And is this our last connection?
It is. I think our next step after this will be to make the physical, or actually connect this stuff to the confetti, the air gun, and then, actually no, let's get the code on there.
Yeah, let's get the code going, and then do the physical.
All right. So now we can send. We've got our display soldered up. We connect the board together here.
We apologize for being out of focus. We'll get it in just one sec. There we go.
Sandwich these together. That is our board with all the connections made. The feather Huzzah is stacked underneath it. And we're ready for code, which means I need to get my computer out. Stow this camera for a little bit because we won't need it again for a moment. Oh, and I also need to...
Vincent Caravella wants to know if you could use the same project to, say, have a robotic arm drop something.
Like a game? You can have this thing do anything like that. Also, hi, Vinny. Okay, so go to our code here, and this is really like most Arduino sketches. Just here's a couple of things that we mashed up together to make things work. In this case, it's the basic Blynk sketch, and Blynk is something where you can use to have it fire, light up an LED or something like that. In this case, we're having it activate a relay. There's a little bit of logic in here of reading the pin state and then displaying, writing out the display, and when it reaches the threshold, that's when it fires off. Of course, there's also this code here, prepare for dramatic animation. That's what we show right before the confetti goes off. There's a couple of things we need to add here. I need to add in my auth key from Blynk. This is something I get from my sketch, and actually I need to go into my email for this. So I'm going to switch away from here. This is a good time for us to also add in our Wi-Fi details. So for any of you who are San Francisco locals, start camping outside our office and freeload off of our Wi-Fi. All right. So those Wi-Fi details are in there. Need to open up my email to get that auth key. Yeah, and the auth key is something that Blynk generates whenever you create a new program within the software, and it's just like a 40-character auth key that basically works as sort of your password into it. It also ends up translating directly into that QR code that's there in the corner that then you can scan and use to interact with the thing. I mean, that's a super useful thing for being able to share your projects because, like in the other case, I have a garage door opener that is activated through Blynk, and I was also able to share that program with my housemates so that they can also use it to get in and out of the garage. So if you have a project that you want to share with other people, that's how you do it. I think this is the correct one.
And the chat is very excited. They say they've been mashing the button this whole time.
Unfortunately, those mashes will not translate to anything just yet. And here's get our Wi-Fi password off of the screen. Maybe? Yes? Okay. So this is the part where we need to decide what our threshold should be. I know it sounds like a lot of you are pretty excited to see this happen, but what number should we set? Right now it's set at 100, which is a nice build-up. If you are just doing this by yourself, but we're not doing this by ourselves, what number should we go with? 500? 1,000?
I think 500 probably sounds good. Let's see. Chat, what do you think we should do? They're trying to guess our passwords.
Whoever guessed password 1234, got it. Actually, no, it's God.
Mike X says 255.
255. I think we might hit that too soon.
That might run through pretty quick.
Yeah.
Oh, somebody else says 5,000. I think we might be here all night in that case. 10,000.
10,000. We can't actually do 10,000 because this is only a 4-digit display. We could do 9999. 512.
I like 512.
Let's go with 512. That's the right answer. All right. So now we need to plug in our board so we can upload our code to it. All right, and so that's plugged in. Feather Huzzah. Yep, it is on port. That's our port, and once we get this code on here, the folks out on the internet that are already trying to test this out, you probably see a little notification in the Blynk app that says that the device is offline. Once we get this code on here and we get it running, you probably should see that update to see where it's actually connecting. And bring the camera back here. See our display lighting up. It's sort of in a predator vision here. Now the other thing to remind you, we can already see.
Oh wow!
We can already see that number is counting up. Now that's not going to do anything just yet. We still need look. That number is just going. This is exciting. Okay, I'm not gonna. Next thing we need to do, of course, is attach this to the. And of course, you don't see directly in real time. The latency on this, the only latency you see is because of the live stream itself. You actually see very, very little latency using the software to control hardware. I would say between like maybe 25 and 50 milliseconds. It's fast.
Yeah, when we were testing it out earlier, I was amazed at how fast it was from button click to iterating.
Okay, so now that that's on there, we can put the computer away. Oh wait, well the computer is actually providing power to it. We'll get back to that later. Because we actually want it to be safe while we're connecting it to the confetti cannon so it doesn't go off when we don't want it to. So come back to us here. And I do want to use my little bits to connect the hardware to the cannon, but we're not going to bother with screws. We're just going to use hot glue. And actually in the drawer there's a bunch of zip ties down in the tool chest.
Yes, I remember.
Yeah, this is all held together with zip ties. And here's our 3D printed parts to hold it all together. Oh, and I lied. I'm not actually done soldering because I still need to put the circuit together for the 9-volt battery connector and all that to basically solder the last little bit of the circuit together, which is not much, but a tiny little bit. We're almost there, I promise. So here's our little battery holder here, which connects with a zip tie. Actually, that one goes down here. Pull this up so people can see it. It seemed like there was a question there about favorite something or other.
is your favorite Dremel bit attachment?
My favorite Dremel bit attachment. Well, usually it's the cutoff wheel.
Yeah, cutting wheel for me too. Most useful.
But recently I bought myself an angle grinder, which is kind of like a really big Dremel, especially with that cutoff wheel. So you can.
Right, you can cut off anything now.
Yeah.
I like the small pointy sander too. I use that a lot for fine tuning 3D prints that I didn't print to fit quite right.
The other thing I've really appreciated recently is that, what if I can get the detail camera back in play here to get some better details rather than just me kind of fiddling about on the big camera. The other thing I've learned recently is that I can really easily chuck in my milling bits, my 1/8 inch milling bits into a Dremel. So if I need to like carve away a little bit of something, you can just put in an 1/8 inch end mill in there, and it works really well. All right, so our next bit here is, where are all these parts? That's the one that holds the board. Should be careful because I have this hot glue gun sitting here on the desk now. Good opportunity for me to burn myself. That's good internet content. Again, we're going to be lazy here and just hot glue everything into place. Actually, I should wait, because I bet I can do some cable management using some of these zip ties. So
wrangling.
So let's move this here. Okay, where's our circuit here?
Do we still need the cable attached? Probably not.
We don't.
Take that.
All right, so I'm going to put some dabs of hot glue onto these little risers that normally you put some like 2.5 millimeter screws into, but we're going to do this the quick and easy way. All right, so that's held into place. Next, we're going to do our display. And that goes into this guy here. Goes in just like this. This one needs some smaller screws that I wasn't able to source immediately. Those are some, I believe, 2 millimeter screws.
Oh, wow. Can you even screw that with a screwdriver, or do you need like tweezers at that point? Tiny little screw heads.
Again, if you've seen this show before, you know that I'm a big fan of the iFixit screwdriver kit, and it has all the bits that you would need to screw in stuff that tiny and even tinier. All right, so now we can continue going back to attaching this to the confetti cannon. Focus in here.
We're getting close, guys.
Super close.
Thank you all for sticking with us. I hope our friends from Italy are still here. Our friends from Germany said take our time because they appreciate good work. So
fantastic. Also, all right. I'm still trying to do this a little bit before I do the last soldering connection I need to make, which is I need to solder one of these solenoid ends to one of the leads for the 9-volt battery clip. So let's get our helping hands helping.
They're still here.
Excellent.
Looks like we have friends from all over the globe. We have somebody from Australia too, watching it during their workday.
Well, happy Friday to that individual.
Paolo Tranchina, it can't wait to fire the cannon. We can't wait for you to fire it either. This is actually my favorite Make Live project this year. When I heard the idea, I was like, that is so stupid and so amazing. I love it. It's not stupid, it's just pointless, which are my favorite projects because you do them for reasons beyond just, I want to make this thing to do this job for me.
It is ridiculous.
Yes, you make it to cause joy or hilarity.
Yeah, had to grab a little bit of shrink tubing here, even though we're working fast and loose, still want to have insulated connections. Because that is the sort of thing that if it touches off in the wrong part, that can close the circuit early.
That would be very dangerous.
Even though that is a really quick and a little bit sloppy, if I might add, soldering job. But
We want to get to firing.
oh, that's how bad that soldering job is.
Oh yeah, that was.
I did not solder anything. I'm going to.
That was a tinning job.
I have now tinned. Actually, I guess I don't need to trim that off and redo that. I can just heat it back up again. That's embarrassing, though.
So doing it with Jason asked what the QR code on the live stream is for. Doing it with Jason, if you download the Blynk app, that's B-L-Y-N-K, and you use your phone to scan that QR code, you could be one of the people mashing the button to fire the confetti cannon. We're going to hook the board that we've been soldering back up once we get it connected to the air cannon, and you will be able to mash your own Blynk button, and the clicks will all add up to 512 and fire our cannon.
Get a little heat on here for the string tubing just to seal up this connection. All right, so that's looking good. Now we can connect this battery connector to our battery. Reposition the camera on it here, and then wire those connections into our relay shield.
Jacob Stevens wants to know where we got the idea for this project.
I got the idea for this project, again, from a few different places. One is the project Twitch Plays Pokemon, and which was a project where somebody connected Twitch chat to a Game Boy emulator to allow people to control the game through like crowdsourced data. And I always wanted to see, like, well, if you can do that, can we have people control hardware? I started thinking about it a little bit more when everybody was busy playing Pokemon Go. I wanted a Twitch Plays Pokemon Go, and somebody did that, but it was all emulated.
Yeah.
And that's no fun.
We thought it would be fun to do a robot.
I wanted an actual robot that would drive around and play Twitch Plays Pokemon Go. Play Pokemon Go. I mentioned earlier, Let's Robot TV actually did that, but in classic internet fashion, the first thing people wanted to do with it was drive it into Lake Merritt in Oakland. Which, that's what happens when you let the internet drive your robot. All right.
Giving the internet too much choice.
Well,
here we've given them a button.
Yeah. There's only one way this can go. And some credit to the idea behind this goes to, well, I mentioned him earlier, and he's here in the chat now, Vincent Caravella. He and I were chatting at one point of like, man, I really want to figure out how to use this hardware to let people interact, let the people who are watching our live streams interact with hardware. And I said, that's a great idea, and I want to figure out how to make that happen. And I will admit that doing this in a way where people need to download an app, I mean, you guys tell me, I think it's a little bit kludgy, but the nice thing about it is that it means that it doesn't matter what platform you're streaming on. I mentioned earlier that this is relatively easy to do with streaming platforms like Twitch, because Twitch's chat is, it's basically just internet relay chat, which is a really old protocol that's really easy to get a board like the Feather Huzzah to sign into.
And you can run all kinds of bots and have interaction go back from them into whatever electronics that you've hooked up there.
Yeah, that's basically how like any of the popular Twitch bots operate, is they just sign into an IRC session, and that's relatively simple to get software to do that. But I wanted something where it didn't matter what platform you were streaming on. In this case, we are streaming to Facebook and to YouTube, and everybody is going to be able to interact with it regardless of what you're doing or how we're connecting. So there are some trade-offs. All right, the last thing I'm doing here is
circling back with power.
Wiring the solenoid valve for the air cannon into the relay. And we can see if we just connect it to the normally closed side. Yeah, I almost wired that wrong. You can maybe hear that. Actually,
click.
I don't know what state this relay is in. I should double check this. Nope, it is, yeah, this is the normally open side far away here. If we touch it to the normally closed side, you can probably hear it clicking there. And that's a electromagnet firing to open a valve that, once we get some compressed air behind it, will shoot air into the sky, or will shoot confetti into the sky. And to make this as safe for us here in the studio as possible, the next step I'm going to do is to fill the chamber with air and get it ready to fire, but only after that am I going to connect power to it, because I don't want it, I know you're all eager to see it fire, but I don't want it to go off in any of our faces.
Now where are we going to set it up so they can see it fire?
I was going to kind of hold it and point it straight up.
Nice. And
hopefully they'll be able to see, well, they'll definitely hear it, and then see the confetti as it's falling. Our last zip tie is...
Carlos Vailard, sorry if I'm mispronouncing that, doesn't know where to press to shoot confetti. It's not on a Twitch stream. If you download the app Blynk, B-L-Y-N-K, and you scan the QR code that we have over the video in the corner, you will be able to, through the app, press the button to fire this cannon here.
Yeah. And by download, we mean it's a mobile phone app.
Yes.
It's available on iOS and Android. And it doesn't matter which one of those platforms you are on in order to interact with this nightmare device.
But hurry up, because we're getting so close now.
We are getting very close. Because the next thing I need to do is fill this thing full of air. And this is a sort of two-stage design where you have this big holding tank here that I'm going to fill up. Actually, first I'm going to, there's two parts to this design here. There's this main holding stage here in my left hand. That's what I'm going to fill up with air, and then you allow air to pass into this section, and that's when it's going to be ready to fire. And then we'll connect the board to power, and then let you start mashing that button to make it go. Hopefully there's enough time for me to get it pointed at the ceiling or just away from us. I'd almost be tempted to fire it straight at the camera, but it might be enough force that it might
actually knock the camera over.
So I'm just filling this up with a standard bicycle pump. There's a little Schrader valve there that all right, so that's about 50 psi in this lower container down here.
I'll take that.
All right, and I'm going to hold my hand over the end here and slowly open this valve to pressurize the firing chamber. So I was experimenting with this earlier and actually was able to fire a little bit of confetti out. So I've got about 30 psi in here now. And try and turn this. Actually, can you hold this straight up like this? I want to see if I can get a close-up shot on that counter. I don't know, can folks see the counter? Oh, it looks like it's really bright.
Mohammed Al-Hamad wants to know if it works for everyone to press a button. That button, if you press it with our QR code, will only fire on this cannon, which we've now faced away from us, so you don't have to worry that if you press a button, you're going to fire it against somebody who doesn't know.
Yeah. Well, I mean, the honest answer is anybody can use the authorization code.
If they have it.
So anybody could download this code and plug it into their board, and see the board is booting up, and it's got that little Predator vision there, and then once it connects, we should be able to see the numbers start counting up.
You guys ready? Opopo wants to know where we got our camera arm from.
This is built by Manfrotto. I think they call it their magic arm, and it is super useful. Like, I would have normally thought, so it's taking a little bit to get connected to our Wi-Fi network and start showing real numbers. But yeah, it's the Manfrotto Magic Arm, and I was really surprised to see that putting the C100 on here is stressing it out a little bit, so I just need to crank it down really far before it connects, or before it gets a really solid connection for the camera. It's a little wobbly, but not too bad. That is taking its sweet time to connect to the network. I think I might give it a quick reset here just in case.
And by reset, we mean turn it on and off again, or turn it off and on again.
All right, come on. Connect. What's going on? Yeah, well, I mean, the other thing to know is this is probably the largest number of people I've ever had connected to a Blynk project trying to use it at once. So we might be stress testing their system a little bit.
Oh, there it goes.
We're seeing it count up. Let's get over to the close-up camera. Don't worry, we will go back to the main camera once we get past, I don't know, 400. Let's see it topping out at 107. I wonder if we might be seeing some latency stuff with
collating.
Just so many people hammering on this at once. This might be useful data for them. I hope so. Maybe we're contributing to research. Blynk is actually developed by a crew of people based out of MIT. So we might see this number kind of rise, or kind of lurch forward a little bit. I hope so. If not, maybe we'll just need to go back into the code and set it to a lower threshold. One way or another, we're going to see this thing fire. We're going to make sure that you guys are doing it. Come back to the main camera here until we see it start to go up a little bit more.
Just in case it lurches to 512 all of a sudden.
Yeah, because you never know. I hope that doesn't happen, but hope to see this start going up again. Please be kind to us, demo gods.
Someone in the chat did say the demo gods strike again.
Yeah, well, sometimes that happens. Come on, Blynk. Don't let us down.
Is there a way that we can look at the Blynk app and see whether or not...
I've actually left my phone charging over at my desk, but if I disconnect here really briefly, I can run and get it, and we can take a look at the app, and maybe I could contribute some of my own
button mashes.
Button mashes. I should have said that while my mic was disconnected.
DJ Lakian says that the Blynk app currently says that the online counter is offline. So once you get plugged back in, we can take a look too.
Oh, that is crazy. Again, I
wow.
need to plug in.
Our button is just a blur.
So I don't know if this is what it looks like for
we're on
everybody.
the big camera.
Oh, we're on the big camera. Okay, let's go to this one here. Yeah, that's what my screen looks like right now, of just everybody in the internet
mashing that button.
That is incredible. But what's happening with our counter here? Has it gone up at all?
Our counter is still at 108, so we have not gone up. So we might want to try maybe fixing the threshold to 100?
Yeah, maybe we need to set that to something a little bit more accessible, because right now we might be mashing so hard that the Blynk servers are breaking. Or maybe they're taking it offline because it's causing headaches for their servers.
I want to unplug him then so that he doesn't go off in our face.
Yeah, that is the thing to consider, because this thing is otherwise is a primed machine.
We'll go ahead and point it this way.
Good call.
I will get you this cable. Okay, we're going to update it real quick just to 100 because we know that we'll reliably reach 100. And I want to let our poor friends in Italy who have stuck with us so long get some sleep. Hopefully they don't have finals or something tomorrow.
And get a little bit more space to plug in the thing. I'm also going to disconnect the 9-volt battery.
Just in case. Safety. Safety eighth.
That will make sure that this doesn't, because I know you guys are hitting that button really hard. And I just want to make sure that this doesn't go off when it goes off when we expect it to. All right, so we're going to change the threshold to, we're going to go back to 100. We're going to hit that really fast, but we're going to get it. So just going to upload this code here super quick. And code is uploaded is at 66% and climbing.
DJ Lachlan says he can feel his phone or her phone overheating from the mashing.
Oh, this is amazing. I've never seen anything like that. That is so crazy to see those numbers go up like that. But that's what happens when you let the internet control your confetti cannon.
Manta Ray says his or her fingers hurt from the mashing, from mashing so many times. Well, hopefully we'll get, this will be our mashing magnum opus, where we all mash till we
the confetti. All right, so order of operations here. The first thing I want to connect is the 9-volt battery to power the solenoid. And then connect the LiPo battery got our predator vision there. When I hold this, I can get the camera position. Actually, I don't think we'd really need to.
Yeah, we might just hit this threshold like one. Oh my God, there it goes. There it goes. Here it comes, guys.
No, please, no.
You mashed too hard.
64. Take a look at the app and see what's. It's still saying it's online. Now it's offline again. All right, I'm going to ask a super huge favor to not have everybody mashing that quickly. I think that's what's breaking it. We're going to restart the board again because now it's offline again. We might just be oversaturating the board.
Yeah, it might just be that the board iteration is.
So I would say maybe only hit it like 1 a second.
Did you pull it? It's still saying 60. It's still got power. That's odd.
That is really bizarre.
There it goes.
Yep. Okay. So let's get more gradual here, button presses here, and I believe we can hit 100.
Here it comes.
And it's and confetti. And that's what happens when you connect the internet to confetti cannon.
Confetti in my hair for weeks, guys. Thank you.
Oh, that was so much fun. And if you guys want to keep mashing, you can make it fire again. But, there's not much point to it now because the confetti is all over the studio and all over the desk and all over us. So if you've been watching this build, this is our internet-connected confetti cannon. Again, it's really dumb. It's fun. And we may have overstressed the Blynk system, but there was really no other way to test this than to do what we just did here. And that's what's really incredible about this stuff. Once again, this is a live stream series that's brought to us, or it's made possible by our friends at DigiKey. If you look down the link below, there's a link there where you can buy all the components that you need to build this project or whatever other electronics project you have in mind. They ship fast. They're a really great company to work with, and we're so thankful that they've powered this entire series throughout the year. Now, we're about to go on a little bit of a break, where we're going to be going home and spending time with our families until the new year. So if you're a fan of our YouTube channel, thank you very much for watching, but we're not going to have any more stuff there until the new year. But we're going to have a lot of great stuff for you then. Thank you so much for watching this. Thank you so much for making this series possible. Of course, it is the gift-giving season, so if you are still looking for gifts for maybe gift ideas for yourself,
They just fired again.
Yeah, there's still a little bit of error still in this pressure, and you made a fire again. Unfortunately, there's not really much more confetti in there. But check out the gift guide on magazine.com, and it's a great resource for cool tools you might not have known about, great gifts for that maker in your life, or maybe good ideas for anybody trying to figure out gifts for you if you're watching this channel. And of course, Make Volume 60, our guide to digital fabrication, is out on newsstands now. So pick that up too.
Beautiful. All you ever wanted to know about digital fabrication, including CNCs, 3D printers, vinyl cutters, laser cutters, the works. And if you want the code for this project or the build for this project, I believe that's also down below in the description.
Yeah, it is, yes. Actually, I think I still need to add it to the one on YouTube, and I'll do that in just a moment. It's certainly in the one on the Facebook live stream. It's also over on magazine.com. You can find it there, as well as lots of other cool projects that you can make and build at home. But once again, thank you so much for watching. Thanks for covering the studio in confetti. Thank you, Hep, for joining me on this stream.
Thanks for having me.
We will see you guys
next year.
In the new year. Thank you again.
Now remember what I told you.
Yeah, don't make eye contact. He takes it as a personal challenge.
Hello? Pat?
Yes?
Can I get a,
He'll take a Raspberry Pi 3.
No pie for you!
Told you. Hey, but I did hear there's a new deli. I can go pick up the sandwiches.
No.
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.